Okay, tying kind of everything together in a nice little bow, we have learned the transformations of quadratic equations like vertical stretch, vertical compress, reflection, translate left, translate right, up and down, whatnot. Then we introduced how that's tied to what we call the vertex form. This is when the vertex is that C and D value, that H and K. The X value is whatever's inside the parentheses, but you have to think the opposite. And then the Y value is whatever's outside the parentheses there. And that tells you technically which way to go with the transformation. The A value just tells you if it's a vertical stretch or compress. If it's positive, then we point the quadratic equation up. If it's negative, then we point the parabola down. Okay. Now, the other form we learned, just like we do with linear forms, is like there's linear, there's slope-intercept form, there's standard form, there's slope point slope form. Just like we have standard form for slope intercept form, we have standard form for the quadratics. So there's vertex form and there's standard form. So the vertex form we've seen honestly the most often for this unit so far. So it's set up like this, where A is your like vertical stretch or compress. If A is positive, it's pointing up. If A is negative, it's pointing down. H and K are your vertex, but when I pull out the H value, it's the opposite. K is just K, and that's just your X and your Y, like what the min and the max are. Like that's your vertex. We practiced today converting it to standard form. Now, standard form should look familiar. It's y equals ax squared plus bx plus c. If you take off the y equals, this should look familiar right here. This is what we learned when we learned how to factor. Remember the slip and slide method or just factoring trinomials? But trust me, we'll wait till after spring break to talk about that. What we're focusing on is, can you convert from vertex form to standard form? So this is where unit 7 comes into play, because we use the FOIL or box method. But before I get ahead of myself, let's look at what this looks like. So if I look at number 1, here's the vertex form. So let's see what information we can pull from the vertex form. First things first is, can you identify what the vertex is? Remember, the vertex is the x and the y value. Now the x is not negative 2, because when I pull it out of the parentheses, it becomes positive 2. The y, though, is positive 3. So what is the vertex? Remember, that's your minimum or your maximum. That's that vertex point right there. Now, is this graph going to point up or down? Well, that's just based off, is it positive or negative out in front? If it's positive, it's going to point upwards, okay? So it's going to look like a graph like this, obviously, and then the vertex is going to be at 2, 3, just like that, okay? Now let's see what it looks like to convert it from vertex form to standard form. So what the most common misconception is they see this 2 outside the parentheses and they just want to distribute it inside. But that's not the power rule for exponents. This is, if you remember what x minus 2 squared means, x minus 2 squared means x minus 2 times x minus 2, something times itself. So we're going to use either the FOIL or box method. For this first one, I'm going to do the box method to refresh your memory. So remember, the box method is just, you draw a square. It's x minus 2 times x minus 2. And you multiply your diagonals. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. If you do it correctly, remember your diagonals add up together. So this piece right here is x squared minus 4x plus 4. Now here's the tricky part. This plus 3 needs to come down after that, because it's still part of the original. Now what does that have to do with it? Well, combine like terms. 4 and 3 are what I can combine. So x squared minus 4x plus 7 is your final answer. So the standard form for vertex form to standard form is y equals x squared minus 4x plus 7. Let's do that again, because I'm sure I lost you. This time I'm going to do the FOIL method. So this x plus 1 is not just x squared plus 1. It's x plus 1 times x plus 1. So if I do the FOIL method, if you remember what that looks like, FOIL stands for first, outer, inner, last. So first, which means technically it's just distributing. I'm going to distribute x first. So x times x is x squared. X times 1 is 1x. 1, then I distribute the 1. 1 times x is x, and 1 times 1 is 1. Now, if you do the FOIL method, you combine the middle two terms. So it's x squared plus 2x plus 1. But just like number 1, this -3 or -3 needs to come down after I've finished that and combine it with the plus 1. So my final answer for standard form is y equals x squared plus 2x minus 2, because 1 plus -3 is minus 2. Now, if I've skipped a few steps there, apologize. The vertex is, from the vertex form, is not 1, -3, but -1, -3, because that's my x, that's my y. I know it's going to point upwards because it's a positive in the front. So it's going to point up, and it has a vertex of -1, -3. But standard form is there. Now, if I look at number 3, this time I have something in front of the parentheses. Now, if we follow like order of operations, okay, I have to take care of the parentheses first. So I'm going to leave the negative out in front. So we're going to FOIL this out. I'm going to resort back to the box method. So I'm going to bounce back and forth for you. So we have x plus 3, x plus 3. X times x is x squared. X times 3 is 3x. X times 3 is 3x. And 3 times 3 is 9. When I combine those two terms, it's x squared plus 6x plus 9. Now, two things happen here. First things first. The x squared plus 6x plus 9 still has this negative out in front. That doesn't mean it just goes to the x squared. It goes to everything that was inside that parentheses. So what does that mean? Well, that means I'm going to distribute the negative times everything inside that parentheses. It does not go to the -3 outside the parentheses. So it just changes all these signs. X squared becomes negative x squared. 6x becomes negative 6x. And 9 becomes negative 9. Now, what I still have at the end is -3. That combines with the -9 and -3. So this standard form is y equals negative x squared minus 6x minus 12. That's standard form. Now, the vertex, if we resort back to the vertex form, is this 3 and -3. But when I pull out this the 3, it becomes -3. And I know it's going to point down this time because the front is negative, the front of the equation. Okay, now where it gets the trickiest, not necessarily tough or hard, it's just longer, is whenever there's actually a number in front of the parentheses. So the same rules still apply over here. We have to take care of the parentheses first. So what I mean by that is we're going to FOIL it out. So I'm going to do x minus 2 times x minus 2. X times x is x squared. X times -2 is -2x. -2 times x is -2x. And -2 times -2 is positive 4. I'm going to combine those middle two terms. So I have x squared minus 4x plus 4. Now, what I still have in front of this entire problem is 1/2. Remember, it doesn't just go to the x squared. It goes to everything that was inside the parentheses. And then I'm going to bring down this minus 4. Okay? Remember, 1/2 only applies to what's inside the parentheses, not the minus 4. So this I'm just going to distribute. Well, 1/2 times x squared is just 1/2 x squared. 1/2 times -4x is -2x. 1/2 times 4 is positive 2. And then I'm just going to bring down this minus 4. So then I combine these like terms. So my final answer is 1/2 x squared minus 2x minus 2. Now, if I look back at the vertex form, my x and my y value is positive 2 and -4. I know it's going to point up because the leading coefficient is positive. If I look at number 5, same rules. I got to take care of this parentheses first. I'm going to go back to the box method to show you both. So x plus 1, x plus 1. X times x is x squared. X times 1 is x. X times 1 is x. 1 times 1 is 1. This combines to equal x squared plus 2x plus 1. This time I have -2 out in front and plus 3 out in back. Now, be careful. The 2 doesn't just apply to the x squared. It goes to everything inside the parentheses. So 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times 1 is 2. And I'm going to bring down this plus 3. So my final step is combine those two. So y equals 2x squared plus 4x plus 5. Now, if I resort back to the vertex form, vertex here is -1, 3. I know it's going to point down this time because it's negative. And I forgot the negative too. Oh, man. All right, got to go back. So negative 2 is actually what I needed to distribute. So this would be negative 4x. This would be negative 2, which when I combine it with that would make it positive 1. So my apologies. I did do that wrong. Changes all the signs. Okay, number 6. So learn my lesson. Let's go back. So we're going to do the FOIL method this time. That means x plus 4 times x plus 4. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. Those two middle terms combine. But I still have negative 3 out in front and plus 1 out in the back. The negative 3 only applies to what's inside the parentheses. So this becomes negative 3x squared minus 24x minus 16, 8, 48, and then bring down this plus 1 so that these two combine. So my final answer is y equals negative 3x squared minus 24x minus 47. If I go back to the vertex form, the 4 and the 1 are the x and the y, but 4 becomes negative 4, and it's just positive 1. I know it's going to point down because the leading coefficient is negative, just like they are in both forms. Okay, so it gets pretty repetitive after that, so you're welcome to stop the video if you understand it, but otherwise I'm just going to finish up the notes. So number 7, x minus 3 times x minus 3. If I do the FOIL method, I have x squared minus 3x plus 9. I combine those two middle terms, so negative 6x plus 9. I still have the 2 out in front and the plus 2 at the end. I distribute the 2, so it's 2x squared minus 12x plus 18. I'm going to bring down that plus 2 so that it combines with the 18. So standard form is y equals 2x squared minus 12x plus 20. The vertex form is negative 3 and 2, but when I bring out that negative 3, it becomes positive 3. I know it's going to point up because it's positive at the very front. If I look at number 8, I'm going to resort back to the box method. So x plus 3, x plus 3. X times x is x squared. X times 3 is 3x. 3 times x is 3x, and 3 times 3 is 9. This becomes x squared plus 6x plus 9, where I still have a 3 out in front and minus 4 in the back. Distribute the 3. 3 times x squared is 3x squared. 3 times 6 is 18x. And 3 times 9 is 27 minus 4 when I bring it down. So that I can combine those two. And then it becomes my final answer, y equals 3x squared plus 18x plus 23. The vertex is 3 and negative 4, but then 3 becomes negative 3, but the 4 remains negative 4. I know it's going to open up because it is positive. If I look at number 9, and this will be the last one that I do. Actually, I'm going to skip to number 12. Okay, then the silent killer is what I call it. So if I look at number 12, yes, I do the x minus 1 times x minus 1, so let's do that first. X times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1x. And negative 1 times negative 1 is plus 1. Those two middle terms combine to be negative 2x plus 1. I still have the negative out in front and negative minus 3 in the back. When I distribute this negative times everything inside, x squared becomes negative x squared, negative 2x becomes positive 2x, and positive 1 becomes minus 1. I bring down that minus 3. So watch out for that silent killer. So my final answer is y equals negative x squared plus 2x minus 4. A vertex form, when I look back, is negative 1, negative 3, but that negative 1 becomes positive 1, and it becomes negative 3, still negative 3. I know it's going to open down because it is negative. Now I'm just going to focus more on just the components. So vertex here is 3 and negative 2, but the 3 becomes negative 3. Negative 2 is still negative 2. If I go, I know it's going to open down because the negative out in front. Number 10, the vertex is negative 2, but when I bring out that first negative 2, it becomes positive 2. I know it's going to open down as well because it's negative. Number 11, negative 2 again. The negative 2 becomes positive 2, and it's going to be negative 2 for the y. It's going to open up because it's positive out in front.